Welcome back to the bench, and today we've got the infamous Focusrite Liquid4, and this apparently has some noise on channel 3. Okay, this is channel 3, I can turn it up. This is obviously the percussive channel. So the power supply looks okay, obviously the rest of the unit's running, so I'm not happy about these relays on these boards. The confuser is underneath here. Hopefully we won't have to touch that. So I think I'll start by looking for some dry joints, clean up this mess, and we'll go from there. And luckily it's all modular designed. So what I find interesting is I'm looking at this op amp on the thermal camera, and we can see that's that glowing one there. That's the next op amp, and this one on the channel 3 is that's 62 degrees as opposed to 38. That one's 38, but our op amp here is 62 degrees, and that's very near the input stage, and I think it's actually making these two chips run hotter as well, because this one is 40 degrees, it's 43, but this one here is 45 degrees and it hardly shows up. So either this chip might be faulty, but I suspect that this op amp has gone faulty. Okay, I've got this board out now. Not quite sure why they put these on stand-up boards. And was it an afterthought? Because they seem to have put the back EMF protection diodes on here as well. And God knows what's happening on this power supply part.
Sun ain't shining, I ain't smiling. Left behind it, crazy times and mad shit in the whole of Iraq. The walls in the backyard, dealers are cracking. Lost souls want the begging and stealing, looking for the next hit so it can relieve them. That's the truth, man, I'm sorry to say. I've done some dark shit in my fucking heyday, but we all learn from our silly mistakes. Some slip away and end up in the race, but they're losing, cause they out of their face. Don't know when to stop and put a foot on the brake, so they take for granted life that they have. I'm spitting out the log and turning this into wow. This is digital imprint of my life in the lab. I'm coming through, chatting real, just skip to the gap.
You need people like me so you can point your fucking fingers. You need people like me so you can point your fucking fingers. I say that's the bad guy.
Yeah, word of warning, I actually melted 2 caps here next to that op amp, so be careful using the hot air gun. So the Liquid4 turns out, as the microphone preamplifier, it's just done on this chip here, which is the Burr Brown PGA 2500. So although it's a very small pitch package and quite difficult to get hold of, I thought I would just quickly swap them around channel 3 and channel 4 to see if the fault changed with swapping the chip over. Okay, looks like we've taken 1 step forward, 2 steps back. So to recap, I've got a bit confused now with the filming. I swapped the two mic preamp chips, and the crackling non-working one, which was on 3, is actually working fine on 4. And then under the heat camera, I noticed that this one was not producing any heat at all compared to the others. In fact, none of these relays were creating any heat. So I managed to figure out that there's an 8-bit shift register here, which does a lot of the control. These looks like protection diodes that go off to the relays. Because there's no relay action here, the signal stays high even on this side of the diodes. So I think there's something in the circuit that was stopping the voltages working correctly. And I did actually find here a transistor which is shorted. So I'm going to have to whip that out. I don't know if you can see that there. There's 2 transistors there. It's the bottom one. So I'll take that out of circuit. I think I'm going to have to take these caps out again. Give me some space. Okay, unfortunately I can't afford to film anything. I don't have enough hard drive space. But I was getting 28 ohms across this transistor, those 2 pins, and I realised I was getting 28 ohms to pin 1 here. But now I've removed this analog switch, I'm not getting the 28 ohms across to there. So I've got a funny feeling that analog switch might have been faulty. So let's get another one in there. Okay, I got everything back together now. I'm surprised if this is going to work. These PCBs are not the most robust in the world. Let's just check the resistance one more time. It's still open circuit. Let's put it back in the box, see what happens. Okay, still no relay action. And if we go to a working one, this transistor stays at -5, it goes to +5, a working one. And on this transistor, it's kind of at 0 and does nothing. I'm wondering whether this short took out that transistor. Might have to take that transistor out. Probably still going to have to take these 2 caps out. So I soldered some wires to the little, what looked like a transistor. And actually, it turns out it's a set of 2 diodes. And I was like, oh, is that blown? Should that be a transistor? But if you look at the datasheet for the PGA 2500 mic preamp, you can see that's part of those 2 diodes there. So they actually measure okay. So I'm going to look further back down the circuit now, because if that chip had blown, I don't know if it's taken anything else out of it. We do have these, looks like protection diodes, which are the control line feeds. And this one here, I can see that it's the 48 volts. And when we probe this, I've lifted this diode to isolate it from the circuit, and we get nothing at that diode. But what is interesting, one good thing that they have done is put little test sockets paralleled onto this ribbon cable, so I can easily probe what's coming from the microconfuser back up to control the board. And it looks like they're using these shift registers in pairs. and I noticed that the 48 volt line comes off this pin here, so it's on channel 4, you can see, and then the same pin on this chip, I'm getting no control. However, if I put my scope into single mode, I figured out now on this connector here, so this will trigger channel 4 when anything happens. And this one here is number 2. Pin 5 along here. 1, 2, 3, 4, 5 is channel 3. Now, we know now that we are actually sending a control signal from the confuser to this top board, but this signal isn't getting to these shift registers correctly. Okay, with that in mind, before I lift the leg, there are a set of transistors here, and I notice that this transistor goes negative 5 volts, this connection negative, and on the broken channel there's a positive 3.4, positive 3.4, and if we go back to the working channel, we're back down to negative. So I need to figure out if this is controlling this, or is this controlling this?
You need people like me so you can point your fucking fingers. You need people like me so you can point your fucking fingers.
Okay, that's interesting. I'm powered up. So these transistors are going to minus 5 volts, minus 5 volts, and now without those shift registers in, that's going down to minus 5. So I am thinking that these shift registers have gone. So let's get some on order. Okay, we're making some progress now. As you can see, all the boards look like they're powered up. And if we go through the unit, this is microphone input 1, line input, and go back to the mic input. So this is channel 2, mic input, and go to the line as well, and we can go back to the mic. And now this is channel 3, which was the broken one. As you can see, it's crystal clear now, and we can switch to the line input. And this is channel 4, which is actually housing the Bob Brown's microphone preamp, which is swapped from 3. So all channels are working. There's just one problem now. Once I've activated, I don't know why I'm speaking into the microphone. Once I've activated a relay on channel 3, the relay stop. If I can get my mic. This is when you turn on the unit. So 4's okay, but 3, I'm allowed one press and then the relay stopped working. So we fixed the initial fault with the crackly sound, which I think actually was part of this switching circuit failing. Oh dear guys, we just reached a showstopper. I was just trying to swap a couple of relays over and this one broke. And I'll see if I can replace this relay. Well, I'm really glad I actually broke that relay, because I decided to order a bunch of them because I wanted to replace all the relays in the faulty channel whilst I was here, and that ended up paying dividends, because now with this Rodecaster mic in phantom power, and it's really clear. Also the relays work properly. So if I go to the line input, and go back to the mic, and we go back to the microphone. So that is incredible. So there's just a couple of things I need to point out to the owner. A couple of relays I've actually put in dip sockets. I've had these relays in and out quite a few times, so I really don't want to risk it and put any more heat on the board. They're really good quality dip sockets, so I don't think the relays will pop out. And because I've melted so many caps with the heat gun, unfortunately this 5.6 nanofarad one, I only have this large cap instead of this normal size. They're really high quality caps, so yeah, I think I can live with that. So that was actually quite really a lot happened in that circuit there, so not quite sure what happened in the end. I'm suspecting that a relay went faulty and took out this chip here, and also took out these shift registers. I put 2 new caps in here and also 2 new bypass caps by these relays as I was there. It cost pence. So yeah, that was quite an interesting repair. So hope you enjoyed that. Catch you next time.
Sun ain't shining, I ain't smiling. Left behind in crazy times and